instead of having 88 in here. To tell Solidity that something is a string, you have to put it in between quotes. I could put really any combination of characters in here, even like hello or follow Patrick on Twitter. And let's actually do uint256 here, favorite number, and we'll do an int256 favorite int equals -88. This way we'll just have an example of all these different types on screen. We can also do an address. So we can say address, my address equals, and we can go into our MetaMask, copy the address, and paste it right into Remix and add that semicolon. And now we have our address type in Remix. And then finally down here, we're going to say a bytes32 object, favorite bytes32 equals cat. And we're going to put it in quotes, just like we did the string up here. And what's interesting about the string object is that strings are actually secretly just bytes objects specifically for text. So a string can actually get converted to a bytes object really easily because under the hood, they're essentially the same thing. Bytes typically look like something like 0x and then a whole bunch of random numbers and letters that represent the hex of whatever the bytes is and can often be represented as strings like cat. We'll talk about bytes more in the future. Similar to uint256 and int256, you can have different size bytes, like bytes 2, bytes 4, bytes 8, etc., all the way up to 32. You can also have just straight up bytes and not have a number after, but that's a slightly different type, and we'll go over that later as well. A uint like this and a uint256 are the same thing, but a bytes 32 and a bytes with nothing are actually different. So keep that in mind for now. The largest bytes, like I was saying, is actually 32. So for example, we can't do a bytes 64. And if we type that in here, Remix actually goes, hey, there's an issue here. And if we try to compile this, we scroll down, we'll again see this little error code here and this little error pop up. It even gives us an output declaration error, identifier not found or not unique. It gives us the line and we can say, whoops-a-daisy, this should be a bytes 32. And we can go back and compile this. For our simple storage contract, let's say that we only want to store a favorite number. This contract is going to be a contract that allows us to store our favorite number and some different people's favorite numbers as well. So we're going to go ahead and delete everything except for the uint256 favorite number. So we're going to go ahead and delete everything and boom. And we'll pick a smaller favorite number just to make it a little mentally easier. Now, these variables actually have default values. So for example, if I don't set my favorite number to anything and I have a line that looks like this, you'll see that this actually compiles fine. Favorite number will actually get defaulted to 0, and all of these types have a different default value. uint256 is 0, booleans is false, etc. So saying uint256 favorite number and not having an equal sign after here is the same as doing uint256 favorite number equals 0. So for now, let's not initialize it to anything so that favorite number starts off as 0. And remember, as you're coding along here and typing along with me, if you get confused, make sure to write your own comments. For example, we can say favorite number gets initialized to 0 if no value is given. Now let's go ahead and learn to make our first function. Basic Solidity functions section. Functions or methods are a subsection of code that when called will execute a very specific small piece of our entire code base. If you're familiar with JavaScript or Python or any other programming language, functions in Solidity are exactly the same. Functions are identified by the keyword function. Let's create a function and name it store. And we're going to have this function be responsible for actually updating our favorite number. We're going to store a new favorite number. So you first write the function keyword, the name of the function, and then you add these two parentheses. Whatever is in between these two parentheses represents what we're going to pass or send to our function, or the parameters that we're going to send to our function. For example, we need to tell our store function what value it should use to update favorite number. So we're going to tell our store function it should take a uint256, and this variable that we're going to pass to it, we're going to call underscore favorite number. It's important that we give it a different name than favorite number up here, and we'll talk about that in a little bit. Then we're going to say this is going to be a public function, and we'll explain that soon too. We want to put these little curly brackets in here as well, and we're just going to say favorite number equals underscore favorite number. And without going too deep into what this is doing, we're saying, I'm not going to explain public yet, but we will in a minute. But what we're saying is whenever you call this store function, you're going to set our favorite number variable to whatever variable that we passed. I'll explain why we do this underscore here as well in a little bit. And with just this, we can actually start to simulate what this smart contract will do and if our store function will actually work correctly. So what we can do with just this code right here is come over back to the compile tab and hit compile, make sure that we get this green check mark and that everything looks good. And then we can go down to this deploy and run transactions tab. Our deploy and run transactions tab has a ton of different parameters in here on how to actually deploy and run with our transactions. We're going to deploy this contract to a simulated virtual environment. So we're going to deploy it basically to a fake environment. We're not going to be deploying it to a testnet. We're going to deploy it basically in kind of an imaginary world. In order for us to do this, first, make sure we're on this Remix VM. And for us, we're going to just use the default, which is the merge. Doesn't really matter which one you're on, just so long as it's the Remix VM. This Remix VM is a fake local blockchain where we don't have to wait for transactions to complete, and we don't have to deal with any of the oddities on deploying our code to a real testnet or a real mainnet. And don't worry about the rest of these for now. We also get an account here. When we run on our fake Remix VM, we get automatically given an account with a different amount of Ethereum for each account. You can think of each one of these accounts similar to our MetaMask accounts in MetaMask, except for these are fake imaginary accounts that Remix just gives to us. For our transactions, including deploying contracts, we're given a gas limit, values that we can send, and we'd also choose our contract depending on which one we've compiled. Since we only have one contract in here, we only have one to choose from. So on the left-hand side, to deploy our contract to this fake Remix VM environment, we're going to go ahead and click the deploy button. If we scroll all the way down to the bottom now, under this deployed contracts, we can see we actually deployed a contract here, simple storage. We can see the balance is 0, and we see this big orange button that says store, and then UNT56 underscore favorite number. On our local blockchain, this at blah, blah, blah here, this is going to be the address of our contract. Similar to our wallets, how they have different addresses, every single contract has a unique address as well. And if we hit this little copy button and we close this and we put it as a comment here and we paste it, we can see this looks exactly similar to an address such as what's in our MetaMask. And then let's go ahead and open the deploy back up and we see that deployed contract is still there. Additionally, if you hit this little show terminal button and you pull this up, we can actually see we have this little comment here, creation of simple storage pending, and we have this green check mark here. This is notating that we actually sent a transaction to deploy this contract. Similar to sending ETH back and forth, in order for us to deploy a contract, we actually have to send a transaction. Since we're doing this on the Remix M, this is a simulated transaction, a pretend transaction inside of our Remix environment. You can even hit the little drop down and see even more information about this transaction. You'll see a lot of familiar keywords like status, transaction hash, from, to, gas, etc. Deploying a contract uses the exact same process as sending a transaction for just ETH. The main difference is we populate this data or input field with a ton of that bytecode. And if you copy this input field or this data field and go ahead and make a comment in here, you'll see it's a massive line. And this massive line notates all the data associated with this smart contract, all the machine readable code. Remember, anytime we do anything that modifies any value on the blockchain, we actually do that by sending a transaction. Deploying a contract is modifying the blockchain, so we do it in a transaction, which means, yes, we spend gas. Now, this big orange button over here actually resembles our function store in our smart contract. And if we add some numbers in here and we call it, again, if we pull the terminal up, we can see transact to simple storage pending, and we see we sent a transaction which called this store. If we do this again with a different number, we call it, we can see our terminal say, oh, you sent another transaction to update the state of the blockchain. And if we scroll all the way up to our account, you'll see that we have a little less Ether in our account because we had to spend the gas associated with, well, A, deploying this contract, and then B, calling these functions. And then, for example, if I add 5 in here and hit store, we'll send a transaction to store 5 on the blockchain. Now you might be thinking, okay, Patrick, that's pretty cool, but what is the value of favorite number? You're telling me that this function store is updating favorite number, but I can't really see it. How do I know that favorite number has actually been updated to 5? Well, the reason we can't see it is that the visibility of our favorite number is actually defaulted to internal. So us not having anything here or right internal are actually meaning the same thing. And we'll talk about visibility and default visibilities in a minute. But in order for us to actually see the value of our favorite number, we'll go ahead and add the public keyword to this. This changes the visibility of favorite number to public. And like I said, we'll talk about visibility in a minute. But let's go ahead and compile this. Let's go ahead and delete this contract by hitting this X here. And let's redeploy this contract with this new public keyword. So let's go ahead and hit deploy. And now if we scroll down and we open up our simple storage, we actually now see a blue button labeled favorite number. And if we click it now, we can see it returns 0, which makes sense because we know that uint256 is default to 0. Now, if I go ahead and add 5 into here and hit the store button, if I pull up the terminal, we'll see that we went ahead and executed that store function call, that transaction that's going to take input this 5 as favorite number and set it to our favorite number. Now, if I hit favorite number, you can see it does indeed return 5, showing that we actually updated our favorite number with this function call. And remember though, I'm going to go ahead and do this again. And remember, when I hit X here, this is just removing it from this window here. If you actually deploy a smart contract to the blockchain, hitting X from this window doesn't do anything because once you deploy your contract, it's immutable, it's out there, and you can't just delete it by clicking X and remix. Functions and variables can have one of 4 different visibility specifiers in Solidity: public, private, external, and internal. If you don't give one of these keywords to your variables, it'll get defaulted to internal. Public functions mean and that they're visible externally and internally. And you'll see here it says it creates a getter function for storage/state variables. This means that other people can call this function or call this variable. When we didn't have a visibility for favorite number, it defaulted to internal, which is why we didn't see this blue number pop up, because internal. It means that other contracts and people aren't allowed to call on this favorite number. We have a little bit more here. It says it actually creates a getter function for storage/state variables. When we add this public keyword here, it's actually equivalent to us making a getter for this favorite number variable, a getter function. And I'll show you exactly what that function will look like in a little bit. Now, keep in mind though, everything on chain is technically public. So setting a function or variable to private isn't a good way to hide what the value actually is there. And we'll talk a little bit more about storage and visibility and that much later. Just remember, everything on these EVM chains is actually public data. This public variable just means any other contract can call this favorite number and see the value what's in favorite number. And private means only the current contract can. External functions mean they're only visible externally. And this is only for functions, not for variables. And it means another function inside this contract couldn't call an external function. And internal means only the current contract and its child contracts can call the function. We'll talk about child contracts and inheritance in a later section. So let's just keep it public for now. The reason that we have this underscore here in this parameter is because we need to tell users that this variable in here is different than favorite number. And there's a couple different conventions on naming local variables versus these what's known as state variables or variables outside of functions. And we'll go over those later in the course. Now, here's something that's really interesting as well. Remember how I told you earlier that sending Ether is a relatively simple transaction, right? Well, let's see what happens when we call this store function and we update favorite number to 5. Let's actually call it one more time. And we hit the little drop down here. Let's go to gas and we'll see gas actually cost 27,000 gas, which is a lot more than the 21,000 gas it costs to just send Ether between accounts. Remember, every time you update the state of the blockchain, it's going to cost gas. Now, what do you think will happen if we do more inside of this store function? For example, we say favorite number equals itself plus 1. Let's go ahead and compile this. Let's delete our old simple storage. Let's deploy this new one. Remember, the last one cost 27 gas. Let's pull up the terminal. And Remix actually gives us a little tooltip. And it's saying an infinite gas, which we know is actually wrong. But let's go ahead and add 1, 2, 3 in here, and we'll hit store. We'll see this transaction. We'll scroll down. We'll see gas is actually a lot more. It's way more gas. It's 50,000 gas with just adding this line here. Now, technically, I'm not telling the full story here because there are some other gas costs associated with the first time you run a function, but it's still more, right? And that's what's important here. So let's go ahead and delete that line and go back to our old function here. Now let's talk about something called scope for a second. So if I create a variable in here called uint256 test var equals 5, and I create a new function called something, we'll make it public. Could I access the test var and then maybe change it to 6 or 7? What about the favorite number var? What about the favorite number variable? Could I access that to 7? Well, let's go ahead and see what happens if we try to compile this. If we try to compile, we actually go ahead and get an error in our compilation, undeclared identifier. Whenever you create a variable, it can only be viewed in the scope of where it is. If that's confusing, just look for the curly brackets. The reason that our something function can read the test var is because this test var isn't inside of the curly brackets of something. The reason it can't read the test var is because test var was created way up here inside of these curly brackets outside of something. But favorite number wasn't created inside of these curly brackets, so how come it knows what favorite number is? Well, something is inside of these curly brackets, and favorite number was created inside of all of these curly brackets. If favorite number was created inside of here, it wouldn't be able to access favorite number because, again, favorite number is inside of this scope and not this scope. If you create a variable like test var inside of store, you can only access this test var inside of this store function and not anywhere else. The easy way to know what the scope of a variable is just look for the curly brackets. So let's go ahead and delete this something variable, and let's delete this test var, and let's recompile. Now, like we were saying earlier, when we add this public keyword to favorite number, it's the exact same as if we created a getter function to return this favorite number. So let's actually write a function similar to what this public keyword is creating. So we're going to say function retrieve. We'll make this a public view function, and we'll talk about that in just a second. And we'll say it returns a uint256, and we'll add the curly braces here. And we'll say return favorite number. And oftentimes when these auto suggestions come up like this, you can just hit enter and they will automatically do it. So if we do favorite and then I just hit enter, boom, automatically like that. Now I'm going to hit Command S, which is equivalent to me going to the compile tab and hitting compile. Now, if I go to the deploy tab, and let's deploy this contract now, when we scroll down, we now see we still have that store function, we have our favorite number function, and we have a new blue button called retrieve. Right now, they both start off as 0. And then obviously if we update this to 5 by calling store, yep, I called store, these now both return 5 since favorite number is the actual variable and retrieve is just returning whatever favorite number is. Now, as you can see here, these two functions are blue, but this one is orange. What's the difference? Why are the colors different? Well, the key is actually with this view keyword here. Solidity has a special keyword which notates functions that don't actually have to run or you don't actually have to send a transaction for you to call them. And those two keywords are going to be view and pure. A function marked view means we're just going to read state from the blockchain. For example, in our retrieve function, we're just going to read what the favorite number variable is. Our store function isn't reading, it's updating something. And it's changing the state of the blockchain. So we have to send a transaction. Since our retrieve function doesn't have anything inside here that updates anything, it just returns favorite number, we don't need to send a transaction. So if you add this view function in here, it disallows any modification of state. For example, I couldn't add favorite number equals favorite number plus 1. If we go ahead and try to compile this, we'll get an error. Function cannot be declared as view because this expression potentially modifies state. So we'd have to remove this line. Or we'd have to remove the view keyword. So view functions disallow updating state, pure functions disallow updating state, and they disallow even reading from state or storage. This favorite number here is what's known as a storage variable because it's stored in a place called storage. We'll talk about that in a later section. But if this was labeled pure, we'd see we get a little red underscore here because favorite number is reading from state. Instead of returning favorite number, we would return something like 7. So this would be an example of a pure function. This would be an example of a view function because we're reading from state. Again, we'll explain the difference a little bit later. And like I was saying before, if we call a view or a pure function, we actually don't need to spend gas since we're not modifying the state. That's why these buttons over here are blue. They're representing view or pure functions, functions that we can call without having to send a transaction. For example, if I pull up the terminal here, and I pull this up, and I call retrieve, we do get another function, but it's just a call, and it looks different than if I hit the store, which has this little check mark. They're different because the store is obviously sending a transaction, and the retrieve is actually just making a call and not sending a transaction. However, something weird is going on here. If I hit retrieve, and I go into the details of this call, I can see, oh, what's this? Why is there an execution cost? It says cost only applies when called by a contract. What's going on there? The reason for that is because if another function that does update state, that does require a transaction, calls retrieve, that transaction does need to pay the gas of reading and calling this retrieve function. So calling a view or pure function actually does cost gas only when a gas cost transaction is calling it. So we can go ahead and call these as much as we want. It costs nothing. But if another function that does cost gas calls it, it's going to cost something. For example, if our function store here then went ahead and called retrieve like this, since store costs gas, you're telling this function, hey, also call this retrieve function, which is more work for it to do. And since it's more work, it's going to cost more gas. So for example, if we delete this contract over here, let's go ahead and compile this. Let's go ahead and deploy this with this retrieve in here. So let's go ahead and look at these. These are now 0. We'll store 5 in here. We'll select the dropdown. We can see how much gas we actually sent. 50,000 gas. Let's go ahead and drop this now. Close this out. Let's remove the retrieve line. Let's compile. We'll hit deploy. Simple storage. These are both 0. We'll add 5, hit store, pull up the terminal, hit the drop down, look at gas. It's still 50,000, but it's actually a little bit less than before. Although I'm pointing at gas, we really should be looking at transaction cost, because gas is really just actually how much we're sending, whereas transaction cost is how much gas the transaction actually cost. But in any case, it was a little bit less without the retrieve function. Now, I've kind of been glossing over this a little bit, but this returns keyword specifies what this function is going to give us when we call it. So when we have this returns keyword in our retrieve function here, we're saying whenever we call this retrieve function, we want to get returned, or we want to be given this favorite number of type uint256. We want to return a uint256 from this function. Now, our contract as is pretty good. It does one thing pretty well. It allows us to store our favorite number, update that favorite number, and then view that favorite number. And in fact, let's go ahead and make this an internal variable, and we'll have the retrieve function be the way to get this. We can have this public, but for now, we're going to set it up like this, and I'll tell you why we're going to set it up like that in the future. But what if we wanted to be able to store not just our favorite number, but other people's favorite numbers as well? Well, what we could do is we could create something called an array, or a list of favorite numbers. What we could do is we could say, instead of just one uint256, we could have a list of uint256 called list of favorite numbers. This bracket syntax here identifies that we have a list of uint256, or a list of numbers, or an array of numbers. An array of numbers is going to look something like this. It's going to have, maybe the first element is going to be 0. Maybe the second favorite number is going to be 78. Maybe the third favorite number is going to be 90. Now, arrays are very common in computer science and programming, and an array in Solidity is exactly the same as an array in any other programming language. If you're unfamiliar with arrays or lists are actually 0 indexed. So the 0 here is actually at index 0. So we refer to this object here as the 0th object, right? This could be 77, and this would be the 0th object. The 78 is going to be the first element, the 90 is going to be the second element, and so on and so forth. It's very common in computer science to actually start counting from the number 0, and arrays start counting from the number 0. We'll learn to play around with arrays more in just a minute. So this list of favorite numbers is great, but how do we know whose favorite number each section is? If this is our list of favorite numbers, how do we know who 0 is, who 78 is, who 90 is, etc.? Well, maybe what we would do, instead of just having a raw list like this, let's go ahead and comment this line out. Maybe we could create a new type called a person. In Solidity, you can actually create your own types using the struct keyword. So we're going to say struct person and do little curly brackets like this. Inside of these curly brackets, we can define what this struct person custom type is comprised of. And we're going to say for every person, they're going to have a uint256 favorite number and a string name. Now, something important to note is, oh, whoops, we have two favorite numbers here. Remember what we learned about scope? Since this favorite number is inside of these curly brackets, these would clash a little bit. So what we're going to do instead is we're going to rename favorite number up here to my favorite number, and we're going to copy paste that down here as well. So we're renaming this state variable, this storage variable, to my favorite number, and just keeping it down here. That way we can have favorite number inside of this struct. In any case, we created this new type of type person, which is a combination of each person has a favorite number and each person also has a name. Now, similar to how we can have a uint256, a Boolean, a string, an int256, etc., we now have a type of person, and this is similar to each one of these. Oh, and we're also going to have to update the retrieve down here with my favorite number instead of favorite number. Now, since we have our own new type, we can actually create a variable of type person the exact same way we created a variable of type my favorite number. So we could say person, visibility will be public, my friend equals, and we'll put person here and put some parentheses here, because when you're working with custom types, you have to define both on the left side and on the right side what type it is. And in here, we would assign a favorite number and a name. So we could say 7 and patch, like that. So now Pat is going to be a person with a favorite number of 7 and a name of Pat. See, the first parameter goes to the first item in the person struct, and the second parameter goes to the second item. I like being a little bit more explicit when working with structs. And actually what you can do is you can put little brackets here instead, and you can say exactly what value you're going to assign to what section. So I can say favorite number is going to be 7 and name is going to be Pat. And we can hit Command S or just go straight to compile to see if it worked correctly, get that little green check mark. Now, by doing this, we've created our own type person, and we've created a variable named Pat with a favorite number of 7 and a name of Pat. Now, if we were to go ahead, let's delete this old simple storage and let's deploy our new simple storage. And we scroll down, we now have a new blue button since this is a public variable called Pat. And if we click the button, if we call this variable, we'll see favorite number of 7 and string name Pat. You can also see this 0 and this 1, which shows the index of each one of these variables or parameters. 0 is for favorite number, 1 is for name. If we added another one, maybe bool is cool would be at index 2. Whenever you create a custom type like this, Solidity will automatically index them, similar to the way that we index our lists or our arrays. Favorite number 0, name 1, whatever's next would be 2, etc. Now, this is great for one friend, but what if you have a lot of friends, which I know a lot of you do because you're taking this course, which automatically means you're cool. Maybe what if you have your friend Mariah that you would like to add to our smart contract like this, and her favorite number is 16. Or maybe your friend John. You'd have to copy paste the line, add John in here. His favorite number is going to be 12, so on and so forth. It might get very tedious to have to write variables for all of these people, for all of these friends. This obviously isn't a great way for us to create lists of people or lists of our friends. So instead of this, we can actually use this array syntax that we just learned and create an array of person or a list of persons. So I'm going to comment all these out for now. And a quick tip here, if you're on a Mac and you highlight a couple, if you're on a Mac and you hit Command / or Command ? It'll automatically comment or uncomment those lines. If you're on a Windows, I believe it is Control /, but you might be able to Google what the actual keyboard shortcut is. This is a keyboard shortcut I use all the time. So what we're going to do now is we're going to create a list or an array of persons. So exact same as we did up here. We'll say our type first is going to be type person array. So we're a type person array. Then we'll state our visibility, which is going to be public. Then we'll get our variable name, which is going to be list of people like this. So we've created a person array with visibility public and the name list of people, and we'll just leave it blank for now. So it'll get defaulted to being an empty list, which would look like this. Now, if I were to go ahead and deploy this, let's delete the last one. Let's compile, deploy. We scroll down, we select this. We now see we have our retrieve blue button, and we also have this blue button for list of people. When you create arrays with a public keyword, instead of being able to see the whole array with this list of people button, you actually have to put in the index of the element you want to work with, and you get to see that exact element. It wants to take a uint256 as an input parameter. However, obviously, our array is blank. So if we say, what is the person at the 0th index? It'll say, well, nothing, because you have a blank array. Well, what about the first index? Well, nothing. What about the second one? Well, nothing. No matter what you put in the box right now, it's going to return nothing. We'll show you how to add to this array in just a second. This kind of array is known as a dynamic array because the size of the array can actually grow and shrink. In Solidity, a dynamic array is signified by what's inside of these little brackets here. If we added a 3 in here, this would be a static array. We're saying this list of people can only have a maximum size of 3. So we can only put 3 persons in this array. Dynamic array, static array. Can have any size, can only go up to 3. Any size up to 3, any size up to 4. Hopefully you get the picture. We're going to work with a dynamic array because we're going to want to add a arbitrary number of people to this